Hi class. Today we're going to talk about minerals, and more specifically we're going to talk about what a mineral is and how you can identify specific minerals. So when I hear students talk about minerals, a lot of times they get confused and they're actually talking about rocks. Rocks and minerals are not the same thing. They're different. A rock is actually an aggregate of many different minerals. So an example that I like to use is think of a house. A house is built from a bunch of different materials, and these minerals are combined together to give you this bigger, more complex structure, the house. So we can think of the house itself as a rock, and the materials it's made up, let's say the bricks, as the minerals. So bricks make up houses, minerals make up rocks. All right? So in order for something to be a mineral, it needs to have 5 specific things. It needs to, first off, be a solid. It can't be a liquid or a gas. It needs to be inorganic, meaning that it's not bone, it's not wood, it's not flesh. Okay? It needs to have a crystal structure. A lot of times this gives minerals reflective properties because the crystal faces reflect light. It needs to have a specific chemical composition. So the atoms in a mineral are arranged in a repeating pattern, okay? And then, of course, it also needs to be naturally occurring, which means that it's not man-made. So in front of me, I have a number of different things. Some of these things are minerals, some of these things are rocks, some of them are neither. I want you to take a moment and look at each of these, and just from my brief explanation, can you pick out which ones are minerals? Okay, well, right off the bat, I'm going to eliminate anything that is not naturally occurring, anything that's man-made. So we have a penny, a nail, and a glass plate. Those are all man-made, so those are not minerals. All right, what about these others? Okay, if we take this one, for example, you'll notice that there are reflective surfaces. It does look naturally occurring. It's definitely solid. It's inorganic. It has all those properties. But what it doesn't have is a definitive and definable chemical composition. And the reason for that is this is actually made up of a few different minerals. You have this mineral right here that's forming a reflective surface. And then you have this mineral right here, which has some different properties. So this is actually a rock that is composed of 2 different minerals. Okay. If we look at this mass right here, this is also a rock. You can see the different colorations within this rock. Those, once again, are different minerals. So you have different minerals that are combined together to form a rock. This right here, this is actually a rock made up of different rocks, which are then made up of minerals. So this is also a rock. So that leaves us with these 3. Okay. Here you have a solid, inorganic, definitely has a crystal structure, has a definable chemical composition. The atoms are arranged over and over in the same pattern within this, and then it's naturally occurring. This right here is a mineral. Okay, so now let's talk about how you can identify a mineral. If you have a random mineral in front of you, what do you do to figure out what it is? Well, each mineral has distinctive properties that help you to identify it. There are many different properties that a mineral can have. I'm going to just touch on a few of these. Okay? The first and most obvious is the color of the mineral. That can really help you narrow it down, but a lot of times it's not the most helpful because actually some minerals can have a few different colors. The next is going to be the luster of the mineral, which is the way that the mineral reflects light. Some minerals will allow light to pass through them. We refer to these minerals as glassy or vitreous because light passes through glass. And minerals that don't allow light to pass through them are referred to as opaque. Some examples of different opaque lusters are earthy lusters, where it just looks like maybe a clump of dirt. It's absorbing light. It's not really reflecting anything. Or metallic luster. So you think of stainless steel. It is reflective. It has that nice sheen to it. And some minerals have metallic lusters. The next property is a mineral's cleavage, which is the direction or planes with which a mineral prefers to break. So once again, minerals are an arrangement of atoms, and these atoms are bonded together. Some of these bonds are weaker than others, and that will actually allow for minerals to prefer to break along very specific planes and plane directions. Okay? And that's different amongst different minerals. Some minerals are bonded so well together that they actually don't have any cleavage planes. And then the next is the mineral's hardness, which once again relates to how well the mineral, the atomic bonds are holding the mineral together. Some minerals are really soft and others are relatively hard. With mineral hardness, we actually can rank the minerals on a scale from 1 to 10. This is referred to as Mohs hardness scale, 10 being the hardest substance that we know of, a diamond, and 1 being the softest. All right, so I have these examples in front of me. I have these 3 minerals, and then I have this rock. So let's start out with identifying or looking at the properties of these minerals, and then see if we can use that to help us figure out the minerals within this rock. All right, so let's start out with the most basic, color. Well, if I look at each of these, there isn't really a color to any of them. Okay. All right, so let's move on to the next one, the luster. Okay, if I hold this up to the light is passing through that one. Light passes, can you see me through that mineral? Light's passing through that one. Light also passes through that one. So all 3 of these have a vitreous luster. Okay, so far they're looking pretty similar, right? All right, let's move on to cleavage. Okay, well, if I start with this one on the right, this one actually has a really prominent cleavage pattern. This mineral actually has a really cool property where I can actually use the cleavage to break it apart. I just split it along some weak atomic bonds within this mineral. Okay. This one, you have the different crystal faces, but there actually are no cleavage planes within this. Instead, this has, when it breaks, it actually breaks in some sort of random pattern, which kind of looks like if you've ever had a chip in a windshield, it's kind of what it looks like. All right, and then this one, you might notice that there are these layers within it. That's one cleavage plane. And then if we look at it from this direction, you can notice that there are these parallel lines and then these parallel lines. So this mineral actually has 3 cleavage planes. So this is helping us now. We have a mineral with 1 cleavage plane, no cleavage planes in this odd-looking fracture pattern, and then 3 cleavage planes. All right, so now let's determine each of these minerals' hardness. And to do that, I have brought with me 3 different tools: a glass plate, a penny, and my fingernail. So on a scale from 1 to 10, the glass plate ranks at about a 5.5 or a 6 in hardness. The penny about a 3 in hardness, and my fingernail about a 2.5 in hardness. So the way that these tools are used, if I take a mineral and I can scratch this tool with the mineral, that means that the mineral is going to be harder than the tool, and vice versa. If the tool scratches the mineral, then the tool is harder. All right, so this glass plate has a hardness of about 6. Can I scratch the mineral? Yes, I can. Okay, so that means this is clearly softer than a 6. Can I scratch it with the penny? You can hear that sound, right? Yeah, it's scratching. Okay, I can scratch it with the penny. All right. So it's less than 3. Can I scratch it with my fingernail? Yep, I can. Okay, so this mineral, I don't have any tool less than my fingernail. So all I know right now is it is less than 2.5. Okay. All right, let's look at this mineral now. Can the glass plate scratch it? I'm not seeing any scratches. Can the mineral scratch the glass plate? Yes, it can. Okay. So that means that this mineral is harder than the glass plate. If this has a hardness of 6, that means this is harder than 6. Okay. All right, so now we're seeing differences in cleavage and hardness. Okay, now let's look at this last mineral. Can it scratch the glass plate? Nope. Can the glass plate scratch the mineral? Yep. I'm just going to try my penny, or my fingernail, not the penny. Can I scratch the mineral with my fingernail? Yep, pretty easily. All right, so that means this mineral is less than 2.5 in hardness. All right, so these two minerals have approximately the same hardness. So the only way we can really tell them apart is through the cleavage patterns. This has 3 different cleavage planes, and this only has 1 cleavage plane. This mineral has no cleavage planes, but has a much greater hardness of greater than 6. Okay. So what I would do now is I would look at a table or a list of mineral properties and try to match the properties that I measured with what's in the table. And if I were to do that, I would find that this is a mineral called muscovite, this is a mineral called quartz, and this is a mineral called gypsum. Okay. So now if I look at this rock, right off the bat, I notice that there is this mineral that has the same sort of cleavage plane where I can just peel it apart. So that seems to match up with this really well. Well, let's see if it has the same hardness. So my fingernail could scratch that. Can my fingernail scratch this? Yes, it can. So this mineral within this rock is the same as this. That's both of those are muscovite. All right, and then I have this other mineral in the middle of this rock, which it's also doesn't really have much of a color. It has this fracture, this way it breaks looks like a chip in a windshield. And I'm just going to quickly see if glass scratches it. I'm not getting glass scratching it. Can I scratch the glass? Yes, I can. Do you see that scratch right there? So this mineral right here and here, that is the same as this. That's quartz. So this is a rock that is composed of both muscovite and quartz. All right. So hopefully that gives you some background on the process that you would go through to identify any mineral that you come across. And I hope that you find that useful.